Welcome, everyone. Today, we are focusing on a critical phase of evaluating the costs and benefits of an AI-powered business solution, analyzing whether to strictly build, buy, or extend AI components. Let us get started. Welcome to our first slide. As solution architects, one of the most pivotal decisions you will make when evaluating the costs and benefits of an AI solution is determining whether to build, buy, or extend AI components. What exactly is this? It is a structured architectural decision model designed to guide your enterprise adoption pathway. The basics are quite straightforward. For every new AI requirement, your organization must decide if it makes sense to create a custom AI component from scratch, acquire a pre-built commercial tool, or customize an existing platform like Microsoft Copilot. Why is this our main focus? Because this single choice dictates the total cost, the time to value, your risk exposure, and the long-term sustainability of the solution. If you choose poorly, you risk massive technical debt or vendor lock-in. How do we make this choice? We blend organizational strategy with a deep understanding of AI cost drivers. As a deep dive, understand that a mature enterprise will actually use a hybrid of all three approaches across different departments. Our goal is to apply this framework systematically to each business process to find the perfect fit. Let us turn our attention to the flowchart on your screen, which visualizes the core of this decision framework. At the very top, everything begins with a specific business process requirement. This requirement flows directly into our central decision gateway, the decision framework node. From here, the path splits based on your strategic needs. If the requirement demands deep customization and control, we take the left path to build custom AI. If it is a standardized workflow where speed is critical, we take the right path to buy pre-built AI. If you need a balance of speed and domain-specific knowledge, we take the middle path to extend AI platforms. Regardless of the path chosen, notice that all three routes converge at the bottom node, enterprise value and ROI. This diagram elegantly illustrates that while the technical execution methods differ wildly, the ultimate objective of every pathway is to deliver measurable return on investment for the organization. Moving to slide 2, let us explore the buy strategy. What does it mean to buy AI? It means acquiring and deploying pre-built, commercial off-the-shelf AI capabilities. The basics of this approach involve leveraging vendor-maintained tools that are already optimized for common industry workflows. So, when should a solution architect recommend this path? The buy strategy is best utilized when rapid time to value is your absolute highest priority, when your internal engineering capacity or AI maturity is limited, and when the underlying business process is highly standardized across the industry. Why is it so appealing? Because it delivers massive efficiency. You bypass the complex development phase, enjoying immediate deployment, robust vendor support, and automatic future upgrades. However, let us deep dive into the risks. While the speed is incredible, buying pre-built AI introduces the risk of vendor lock-in. You are also constrained by limited extensibility. If your organization has a highly specialized, proprietary sub-process, the pre-built tool may have feature gaps that you simply cannot patch. You trade control for convenience. Take a look at this horizontal flowchart detailing the buy strategy lifecycle. We start on the left with a standardized process. Because the process is standard, we immediately move to evaluate SaaS vendor. This leads to a crucial decision gate, vendor fit. If the vendor's capabilities match our needs, we proceed along the solid yes path to deploy pre-built AI. This action results in our desired outcome, rapid time to value, which is the primary benefit of buying. However, observe the dotted lines branching off the deployment node. These represent the inherent architectural risks we must accept and manage, the risk of vendor lock-in, and the risk of feature gaps. This visual clearly demonstrates to stakeholders that while buying is the fastest route to AI enablement, it is not without long-term operational compromises that must be continuously monitored. On slide 3, we examine the extend strategy. What is this approach? It involves customizing an existing, mature AI platform like Microsoft Copilot, Copilot Studio, or Microsoft Foundry so that it adopts your specific internal business logic. The basics involve taking a powerful base model and wrapping it with line-of-business prompts, custom plugins, and internal knowledge sources. When is this the right choice? It is perfect for hybrid scenarios where the base model performs excellently, but you need a blend of rapid deployment speed and enterprise-specific adaptation. Why do architects love the extend approach? Because it offers the ultimate Goldilocks scenario. It provides a beautifully balanced cost structure. It is significantly faster and cheaper to deploy than building from scratch, yet it offers infinitely more customization flexibility than simply buying a rigid software package. Diving deeper into the architecture, the success of the Extend strategy relies entirely on data. To make the base AI behave like a proprietary tool, you must inject domain-specific knowledge through high-quality grounding data, strict semantic indexing, and secure API connectors. Let us walk through the architecture diagram for the Extend strategy. At the top, we have our foundation, the base AI platform, such as Microsoft 365 Copilot. To make this generic tool specialized, we introduce the extension layer directly below it. From this layer, the architecture splits into 3 parallel customization methods. On the left, we inject custom prompts to shape the model's behavior and tone. In the center, we connect domain grounding data so the AI can read our private corporate documents. On the right, we attach custom plugins and skills to allow the AI to take action in our external systems. Finally, all 3 of these powerful extensions merge back together at the bottom to create a fully tailored business agent. This diagram perfectly illustrates how extending a platform leverages a massive existing infrastructure while still delivering a highly bespoke, business-aligned solution. Slide 4 brings us to the build strategy. What does it mean to build? It means creating AI components internally from the ground up, bypassing SaaS tools to work directly with raw infrastructure and custom model pipelines. The basics of building involve fine-tuning language models, engineering bespoke orchestration frameworks, and taking full responsibility for the AI's operational hosting. When is this extreme approach justified? You should only build when your organization requires absolute, deep customization, complete control over intellectual property, or complex integration with highly proprietary legacy systems that commercial tools cannot reach. Why go through the effort? Because building provides ultimate control over data privacy and model behavior. It is the only path that allows you to create truly unique workflows that serve as a competitive differentiator in your market. However, our deep dive reveals severe architectural risks. Building custom AI demands the highest upfront capital expenditure, requires the longest implementation timelines, and commits your organization to a continuous, expensive cycle of specialized maintenance and model retraining. Observe the flow of the build strategy on your screen. It begins at the top with a unique business requirement, a scenario that off-the-shelf tools simply cannot handle. This necessitates a move to custom AI engineering. From there, the massive workload is divided into 3 complex pillars: model fine-tuning for custom intelligence, bespoke orchestration for managing AI logic, and proprietary integration for connecting to legacy databases. These 3 demanding technical pillars converge to deliver high competitive differentiation, the ultimate prize of building your own AI. However, there is a critical caveat shown at the bottom. A dotted line points from our success node to a warning node, high upfront cost and maintenance. This diagram is a stark reminder to business leaders that while building custom AI unlocks unparalleled capabilities and market advantages, it permanently binds the organization to significant ongoing financial and technical commitments. Now that we understand the 3 options, how do we choose? Slide 5 covers evaluating strategic business drivers. What is this evaluation? It is the process of analyzing your core business motivations to ensure your technical AI path aligns perfectly with corporate goals. The basics require architects to ruthlessly weigh process uniqueness, strategic importance, time horizons, and regulatory compliance needs. Why is this evaluation non-negotiable? Because mismatching the strategy is disastrous. If you deploy a multi-million-dollar custom build for a basic commodity workflow like email triage, you waste money. Conversely, if you buy a generic SaaS tool for your company's core differentiator, you immediately lose your competitive edge. How do we do this practically? We map every business process on a spectrum from commodity to differentiator. In our deep dive, we look at the time horizon. If the business demands an immediate operational win, you must choose, buy, or extend. If leadership is aiming for a long-term, highly defensible strategic capability, that justifies the massive investment required to build. This decision tree diagram provides a clear, visual methodology for mapping business drivers to architectural choices. We start at the critical decision gateway, strategic importance. If the process is evaluated as a commodity workflow, something every business does, like basic HR onboarding, the flow directs you to prioritize BY, leading to the ultimate goal to optimize for speed. If the process is domain-specific but doesn't require reinventing the wheel, we follow the middle path to prioritize extend, which allows us to optimize for balance between cost and customization. Finally, if the process is your organization's core differentiator, your secret sauce, the flow mandates that you prioritize build, ensuring you optimize for control over your intellectual property. This diagram is the ultimate cheat sheet for ensuring your technical AI architecture accurately reflects your overarching corporate strategy. To evaluate costs effectively, we must thoroughly understand total cost of ownership, or TCO, covered on slide 6. What is TCO in this context? It is a comprehensive financial model that captures every single direct and indirect cost across the entire lifecycle of your AI solution. The basics rely on Microsoft's cost structure guidance, which divides TCO into 5 mandatory domains: infrastructure, development and integration, data quality, expertise, and operations. Why do we rigorously model this? Because historically, organizations only budget for software licensing, completely underestimating ongoing maintenance and data preparation costs, which leads to stalled projects and broken ROI promises. How do you calculate this? You must forecast compute costs for inference, API integration hours, data labeling efforts, staffing for ML engineers, and the cost of continuous telemetry monitoring. For our deep dive, pay special attention to the data quality domain. Cleansing unstructured data, building vector indexes, and monitoring for semantic drift almost always represent the largest hidden, ongoing expenditure when you choose to build or extend. Let us break down the TCO structure using the diagram on your screen. The primary node, AI total cost of ownership, branches out into the 5 critical cost domains every solution architect must evaluate. We have infrastructure and compute, dev and integration, data quality and indexing, expertise and staffing, and finally, ops, licensing and monitoring. Notice the dotted lines leading from the infrastructure and data quality nodes down to the hidden costs warning node. This is a vital architectural insight. While development and licensing are usually well documented upfront, the costs associated with scaling GPU compute inference and continuously cleansing data to prevent model hallucination often catch organizations off guard. By visualizing all 5 pillars simultaneously, you ensure that your financial models are durable and that your executive stakeholders are fully aware of the true lifecycle costs before they commit to an AI deployment pathway. Slide 7 brings our methodology together into a step-by-step architectural decision flow. What is this? It is the formal, 9-step sequence that solution architects use to officially navigate the build, buy, or extend evaluation. The basics involve a highly structured progression, starting with raw business requirements, moving to vendor assessment, conducting TCO estimation, and finishing with a mathematical scoring model. Why do we enforce this rigid process? Because AI is heavily hyped. This workflow provides a defensible, data-driven framework that completely removes emotional bias and hype from your technology selection. How do you execute it? You define the process, determine its strategic weight, check if a vendor SaaS solution exists, evaluate the feasibility of extending or building, calculate your 5-domain TCO, forecast your ROI, score the options, and finally, make your selection. Diving deeper, the critical bottleneck is step 6 and 7. You must aggressively estimate the TCO and forecast the tangible ROI like hard time saved or error reduction before you ever attempt to score the options on your weighted decision matrix. This sequential flowchart maps out the exact life cycle of an AI architectural decision. We begin at step 1, defining the business requirements, moving smoothly into step 2 to determine strategic value. At step 3, we hit a major logical fork. Does a vendor solution exist? If yes, we follow the path to assess buying or extending. If no, we are forced down the path to evaluate a custom build. Importantly, both paths merge back together at step 6. Regardless of the technical approach, you must estimate 5-domain TCO. This flows directly into step 7, forecast ROI benefits. By mathematically comparing the TCO against the ROI, we move to step 8, where we score weighted options objectively. This highly disciplined, linear flow ensures that by the time you reach step 9, select optimal path, your recommendation is bulletproof, backed by both strategic alignment and rigorous financial forecasting. Our final slide focuses on synthesizing TCO and ROI to make your final decision. What are we doing here? We are taking our quantified business benefits and comparing them directly against our lifecycle costs to determine the optimal value to cost ratio. The basics are pure mathematics. Your net benefit is your annual benefit minus your annual TCO. Your ROI percentage is that net benefit divided by the TCO. Why is this final calculation so vital? Because it ensures the organization selects the exact approach, build, buy, or extend that maximizes long-term value without breaching risk or budgetary constraints. How do you present this? As an architect, you should build a sensitivity analysis showing optimistic, expected, and conservative bands so stakeholders clearly understand the financial volatility of the AI project. For our final deep dive, consider this scenario. If buying an AI tool yields 80% of the required business value, but only costs 20% of what a custom build would cost, the value-to-cost ratio strongly dictates that you buy. You only deviate from that math if the missing 20% represents your absolute core business differentiator. Our final diagram illustrates the financial synthesis required to finalize your AI strategy. On the left, we input two crucial metrics: the annual gross benefit representing the time and money saved by the AI and the annual TCO lifecycle, representing our 5 cost domains. These two inputs feed directly into the central processing node, where we calculate net benefit and ROI. The output flows into a sensitivity analysis node, ensuring we account for optimistic and conservative adoption scenarios. This rigorous financial filtering leads us to the optimal value-to-cost ratio. It is only after determining this ratio that the arrow points to our ultimate conclusion, the final architectural decision. This visual reinforces that deciding whether to build, buy, or extend is never just a technology question. It is fundamentally a business economics equation that must be solved using discipline and data.